We now continue our look at Alberta Science Outcome 9C3 with a focus on hazardous chemicals. Students will comprehend information on the biological impacts of hazardous chemicals on local and global environments by interpreting evidence for environmental changes in the vicinity of a substance release, interpreting LD50 data and other information on toxicity, and identifying concerns with the disposal of domestic wastes, such as paints and oils, and industrial wastes. Introduction. Hazardous chemicals can have serious impacts on both local and global environments. Understanding these impacts is important for making informed decisions about chemical use, storage, and disposal. In this video, we will explore how to interpret evidence for environmental changes near a substance release, how to understand toxicity data such as LD50, and why proper disposal of domestic and industrial wastes is crucial. Evidence for environmental changes near a substance release. When a hazardous chemical is released into the environment, scientists and environmental workers look for signs that the local ecosystem has been affected. These signs can include changes in water quality, soil composition, plant health, and animal populations. For example, if a factory accidentally releases a toxic chemical into a nearby river, the water may become cloudy, fish may die, and plants along the riverbank may wilt or turn yellow. These changes are evidence that the chemical is harming the environment. To gather evidence, scientists may take samples of water, soil, or air before and after the release. They compare these samples to see if there are differences in chemical concentrations, pH levels, or the presence of harmful substances. If the concentration of a chemical increases dramatically after a release, it is a clear sign that the environment has been contaminated. Scientists also observe the behavior and health of local wildlife. If animals are found dead or behaving unusually, it may indicate that the chemical is toxic to them. Interpreting LD50 data and other information on toxicity. One important way to measure how dangerous a chemical is involves looking at its toxicity. Toxicity refers to how harmful a substance is to living things. A common measure of toxicity is LD50, which stands for lethal dose 50%. LD50 is the amount of a substance that will kill 50% of a test population, usually laboratory animals if ingested, inhaled, or absorbed through the skin. LD50 values are usually given in milligrams of substance per kilogram of body weight, milligrams per kilogram. For example, if a chemical has an LD50 of 10 milligrams per kilogram, it means that a dose of 10 milligrams per kilogram of body weight is expected to kill half of the test animals. So if your test animals weigh 10 kilograms each, dosing them with 100 milligrams per kilogram, or milligrams of the substance, is expected to kill half the population. The lower the LD50 values, the more toxic the substance is. Remember, it's not directly measuring toxicity, it's measuring the quantity of the toxin that kills half the population. So more toxic substances need lower doses to kill, so those are smaller LD50 values. For instance, a chemical with an LD50 of 5 milligrams per kilogram is more dangerous than one with an LD50 of 500 milligrams per kilogram. If you give a 1 kilogram animal 50 milligrams of both of these substances, that first one, 50 milligrams, is 10 times the likely lethal dose. The animal is probably gone. The other one, you have to get to 500 milligrams before you lose half the population. If you only give 50, they're probably going to survive, although they may not have a pleasant experience. It is important to remember that LD50 values can vary depending on the species tested, the method of exposure, and other factors. Humans may react differently to a chemical than mice or rats. Also, LD50 only measures acute toxicity, which is the effect of a single large dose. Some chemicals may be less dangerous in the short term, but can cause serious health problems if exposure happens over a long period. That's chronic toxicity. So you could have something where 10 milligrams will kill you if you get it all at once. But if you only have 5 milligrams, you're fine in the week with no long-term damage. There's something else where it may take 100 milligrams to kill you, but it stays in your body. So 1 milligram a week will kill you in 2 weeks. Other information on toxicity includes the effects of chemicals on organs, the potential for cancer, the carcinogenicity, and whether a substance can cause birth defects, teratogenicity. Scientists use this data to decide how chemicals should be handled, stored, and disposed of safely. Concerns with the disposal of domestic and industrial wastes. Many hazardous chemicals are found in everyday products such as paints, oils, cleaning agents, and batteries. When these products are thrown away, they can end up in landfills, sewers, or even natural environments. Improper disposal of domestic wastes can lead to pollution of soil and water, harming plants, animals, and humans. For example, pouring paint or motor oil down the drain can contaminate water supplies. These substances may contain heavy metals or toxic compounds that are difficult to remove from water. In landfills, chemicals can leak into the ground and reach underground water sources, affecting drinking water and agriculture. Industrial wastes are often more concentrated and dangerous than domestic wastes. Factories may produce large amounts of hazardous chemicals as byproducts. If these wastes are not treated or disposed of properly, they could cause major environmental disasters. For example, spills of industrial chemicals can kill fish, destroy habitats, and make land unusable for farming. To prevent these problems, there are strict regulations in Canada about how hazardous wastes must be handled. People are encouraged to take paints, oils, and other dangerous products to special recycling or disposal centers. Industries must follow laws that require them to treat wastes before releasing them into the environment. These measures help protect ecosystems and human health. In conclusion, hazardous chemicals can have serious biological impacts on both local and global environments. By interpreting evidence for environmental changes, understanding toxicity data like LD50, and recognizing the importance of proper waste disposal, we can make better choices to protect our planet. It is important for everyone, from students to industry workers, to be aware of the risks and responsibilities associated with hazardous chemicals. By learning about these issues, we can help ensure a safer and healthier environment for all living things. Let's check for understanding. What does LD50 represent in toxicology? The dose required to kill 50% of a test population, the dose required to kill 100% of a test population, the dose required to have no effect on a test population, or the dose required to cure 50% of a test population. Pause now if you need more time. LD50 represents the dose required to kill 50% of a test population. Which of the following is a potential environmental change due to the release of hazardous chemicals? Is it enhanced plant growth, increased biodiversity, improved air quality, or soil contamination? Pause if you need more time. It is our last option, soil contamination. Why is it important to properly dispose of domestic wastes like paints and oils? Is it because they are beneficial to wildlife? They can contaminate water sources. They can improve soil fertility, or they decompose quickly. Pause if you need more time. They can contaminate water sources. What is a common concern with the disposal of industrial wastes? Is it that they are always biodegradable, they are non-toxic, they could lead to habitat destruction, or they improve air quality? Pause if you need more time. They can lead to habitat destruction. How can interpreting LD50 data help in assessing the risk of a chemical? It helps determine the potential lethality of the chemical. It indicates the chemical's effectiveness as a fertilizer. It measures the chemical's ability to enhance growth, or it shows the chemical's nutritional value. Pause if you need more time. It helps determine the potential lethality of the chemical. If you have any questions or feedback, please leave them in the comments, and I will try to respond in a timely fashion.